I love also, by the way, how much you're note-taking. We already had to extend the notes columns in there, and we're not even doing the breakouts yet. So you're doing a really wonderful job. Thank you so much. Okay, next one up here, we have Tanya Berger-Wolf. Thank you so much for joining us. And you're going to tag team also onto this, and you're going to tell us a little bit more about nature challenges. And so we've already had a few of them. Now we're going to really complete that list, at least the first round of those. Thank you so much for joining us. Really appreciate it.
Thank you for having me. And so I'm Tanya Berger-Wolf. There is a long list of collection of icons and that represent various hats that I wear. All of them fabulous. So Galland and I, we did not coordinate it, but it's a perfect setup. So, you probably have seen all these kinds of headlines that the world is unnoticed, that we're losing biodiversity at an unprecedented rate, as was pointed out. We're in the middle of the sixth extinction. So about 1 million species face extinction. Quick quiz, is it a lot or a little? How many species of living organisms are out there, estimated, total, on Earth? Order of magnitude. If you know the answer, if you actually know the answer, hold on. So what do you think? What do you think is the answer?
10 million.
10 million. Going up? More? Less? What's the order of magnitude? So think of all the plants, animals, all the fungi, everything. Like how many? 100 million?
Going up if you're including fungi.
All right. So the estimate is actually about 10 million. It's a shockingly low number, right? It's a shockingly low number because that means that we're about 10% of the world's biodiversity is facing extinction. Right? I know, it seems like there should be more. But we've had now estimates over and over again that put the number around there. And so the challenges that the natural systems are facing, right, that the nature of this planet is facing. We already talked about biodiversity, but it's all connected, right? Biodiversity is only one aspect of the problem. It's part of functioning ecosystems that provide ecosystem services on which our own well-being is actually dependent. And so climate is interwoven, but it's not only climate, as it was pointed out. There is also, the overwhelming, everything that's happening, and we're the culprit in most of it, is overwhelming the capacity of ecosystems to respond, and to respond in time, right? And to recover. It is causing the biodiversity loss, and the species that used to be bountiful are disappearing. It also shifting the timing. So the timing of critical biological events and the sort of the functioning, the concert of timings and dynamics of ecosystems is disrupted, and they're out of whack. And so there's a loss of habitat, there's this disintegration of ecosystem functioning. And then the thing is also, we focus on one species or a subset of species. It is very difficult to really manage the entire ecosystem and to understand the entire ecosystem. And so there are a couple of challenges that I would like to point out then. One challenge is data. So it's been pointed out that biodiversity has a data problem. So we actually don't know how much we're losing and how fast. We don't know what's happening with the changes. Of the 10 million about species that are estimated to be out there, we've only described about 2.1 million. 2.1 million, right? And it is especially acute for species that are rare, that are on the cusp of being lost, because they're hard to see, to observe, right? It's particularly true for fragile ecosystems. The data that we do have is hugely biased, and there's also no data on things that have not yet happened, but will. So to make it explicit, the International Unit for Conservation of Nature Red List, which is the official organization that determines the conservation status of species out there. So when we say the species are endangered, it's because the Species Commission for that species of IUCN Red List determined that by some criteria, the status should be endangered. So of the 2.1 million species that they described, about 160,000 that they actually have full listings for. Of those 160,000, more than half, their conservation status is data deficient or their population trend is unknown. That's not having data. We cannot make decisions if the official conservation status is data deficient, and it's not obscure species, it's killer whales. And the iconic conservation species like polar bears, right? And the data that we do have right now, even if we collect all kinds of and be creative about data. So this is the map of biodiversity hotspots of the world, not surprising where they are. This is the loss of biodiversity overlaid. This is the GBIF data, right? The Global Biodiversity Initiative Fund. So this is, notice the bias where we don't have data is exactly where the biodiversity is the highest. This is a naturalist data, which is the Nature Observations citizen science platform. This is eBird data. So there's the kind of almost complementary bias to where the biodiversity is highest. The second challenge is understanding. These, as I said, ecosystems are complex. We can know individual parts. We've studied some, but it's very hard to understand the system and the functioning of these complex systems, to understand the drivers of biodiversity loss and functioning and changes. So here the same ones that have been just mentioned, but really how they impact, what is happening to the entire ecosystems and the complex interactions. What is the impact of different interventions that are possible? Should we put land aside? Should we do rewilding? Should we do conservation? Should we do coexistence? What are the policies that are working? And what are the downstream effects of these of ecosystem changes on everything else, right? The third challenge is resources. It is a hugely under-resourced area, right? And we're not scaling our observations and understanding fast enough just to keep up with the impacts. And it's not only about money, although money is a huge problem. This is the recent report on the financial gap. But it is also the lack of people, expertise, tools, and metrics to actually make these decisions. And the final challenge then is indeed policy and action. So there's so many different things that we could be doing, and everybody is doing them locally. And these are quite often uncoordinated and hard to evaluate. And so we need to really make policy decisions that rely on good data, that support, that there's analysis to support prioritization, design, implementation, enforcement. And this is the hopeful message that we can be the force for good in restoring ecosystems if we understand what works and what doesn't. And if we do, if we succeed, the payoff is huge, right? So with that, hope we rise to the challenge.
Sure. I'm just wondering, there's this concept in AI image generation called in-painting. So where you get part of an image and you erase part of it and you're like, okay, fill this with something else. If this is a decisive decade, it seems like we're going to have approximate models. I'm just wondering what is known from the world of ecology that is at least a sort of first principles, high-level basic model, like thermodynamics, like here's the primary production, here's the energy in different trophic cascades, here's where nitrogen is flowing, stuff that we can measure, and then we can infill using ecosystem models. What I would love to know is how good is the basic framework which we can start to in-paint with AI?
There is a lot. There's a lot that we do know. We're not starting from zero. The two caveats are that what we know is for the bulk of kind of the distribution, right? The core of the ecosystems, the core of the species ranges, the current state. We've never experienced the type of dynamics, so we can predict some aspects, right? So we also don't know very well what happens at species ranges at the edge of there, and what happens with the species that are rare. So there's a lot that we do know, we can infer, but even the basic number of estimating the number of species, the best estimates are just 2 years old. Like this is the state, but we're not starting from zero, and there is a lot that AI can do. We just got funding from the National Science Foundation. Thank you, NSF, with people who are with organizations who are here partners on AI for Biodiversity Change, ABC Global Climate Center. So to do exactly that, how can we take what's known and extend to what we don't know and make really, really good educated guesses, right?
Thank you so much. Wonderful. Thank you.